Assalamualaikum and greetings to all lecturers. My name is Afiffy Farihin Bin Abd Razak and I have been supervised by Prof. Dr. Syarullail bin Samion. My final year project title is about wear resistance of palm oil with nanoparticles additive at high applied load. Throughout this presentation, I will cover on 5 main topics, which are introduction, literature review, methodology, results and discussion, and conclusion. So first and foremost, for introduction, let me give a little exposure on how wear can occur and affect a machine. It is first because of the friction happen between two body contacts, which can lead to wear and heat. Then it will slowly damage the machine. That is why it's very important to pour lubricant so that the friction can be reduced. But nowadays, engine oil as lubricant is very expensive due to limited resources and it is not environmental friendly. So many researchers found an alternative ways to use palm oil as replacement for engine oil, as palm oil has lower friction and reduce environmental hazards such as human health and pollution. Palm oil is renewable and biodegradable. However, palm oil has its weakness, which is oxidation when it comes to high temperature. Thus can increase the wear. So, nanoparticles additive is needed to mix with palm oil for improvement. One of the good additives is molybdenum disulfide or MOS2. It is because MOS2 can reduce the friction and wear rate. It is also can sustain at high load application and durability to withstand heat and pressure, which usually have been used widely by Germany lubricant company, which is Liquimoly. That's all for a brief introduction. Next, I will go into the objective of the project. The objective of this project is first to determine the coefficient of friction of palm oil with and without nanoparticles and compare with engine oil. Second is to analyze the wear scar behavior on sliding ball for each lubricant used. The scope and limitations for this project is by using palm oil mixed with 0.05% of weightage of molybdenum disulfide as lubricant compared with palm oil alone and engine oil. Second is by using a linear reciprocating tribo tester, which is the variable load is 50 Newton, 100 Newton, 150 Newton, and 200 Newton. The frequency speed is 2 Hz and the lubricant temperature is 100 degrees Celsius. The steel ball has 10 mm diameter while the steel plate SKD11 has dimension of 2 cm. Zuan et al. Has made his research on performance of palm oil at various loads, and his finding is as normal load increase, value of COF decrease. Second, the COF obtained by palm kernel oil is lower than semi-synthetic engine oil. And also, the wound surface for PK oil, which is palm kernel oil, is smoother compared to semi-synthetic engine oil. There is another research by Karu et al. On advantage of molybdenum disulfide as additive. His findings are coefficient of friction is lower when mixed with MOS2 compared to engine oil alone. Second, as the size and concentration of particles decrease, the COF also will be decreased. This is because of nanoparticles have a larger surface area to volume ratio. Many of the chemical and physical interactions are governed by surfaces and surface properties. So, nanoparticles with a higher surface area can give better properties than microparticles. For methodology, this is my apparatus and equipment, which are linear reciprocating tribometer setup, specimen SKD11 plate with dimension of 20 mm, steel ball bearing with diameter of 10 mm, microscope, preparation of lubricant, acetone, and tissue. Okay, so for the procedure to conduct experiment by using linear reciprocating tribo tester, first we have to wash and wipe all apparatus with acetone to make sure the apparatus is clean. Second, clamp the bearing ball into the tribometer arm. Third, place the flat plate into the specimen housing, then apply the load to the tribo tester, then fill the lubricant around the specimen using syringe about 13 to 20 ml until it reaches the surface of the ball bearing. Then you have to set the parameters on the software of the computer. Until that, it's time to run the test. That's all for the procedure to conduct the experiment by using linear reciprocating tribo tester. Next, this is my experimental condition, same as what I mentioned in scope for the study. The testing time is 10 minutes and with constant frequency of 2 Hz and using 3 lubricants, which is palm oil mixed with molybdenum disulfide, palm olein, and engine oil. This is my Gantt chart for overall semester on completing this project. Next, I would like to present my results and discussion, which have 3 subtopics, which is first, coefficient of friction, second, wear scar diameter, and third, wear worn surface. For the coefficient of friction, this is my graph, which the COF versus load, and the justification is first, the coefficient of friction value for palm oil when mixed with molybdenum sulfide is lower than engine oil and palm oil at all load applied. This is because the hexagonal structure of molybdenum sulfide that form a protective layer on the surface. From the graph also, we can see at load 50 Newton to 150 Newton, the value of COF for palm oil mixed with MOS2 increased from 0.055 to 0.069. However, at 200 Newton, it decreased to 0.066. Next. The COF value for palm oil is lower than engine oil at all load. This is because palm oil has fatty acid structure that can act as film layer on the surface, therefore reduce the coefficient of friction. We can see also at 200 Newton, there is about 16.5% difference on COF for palm oil and engine oil. Next. The coefficient of friction value decreased as load approaching 200 Newton for all lubricant, mainly is because the wear debris produced will act as protective layer to overcome high frictional force and metal-to-metal direct contact and resulted to the lower value of COF. Next, for the wear scar diameter, this is my graph of the result, which is wear scar diameter in micrometer versus load. So for the justification, first, as the load increased, the wear scar diameter for all lubricant also increased. The reason behind this is because the formation of shear stress on the metal-metal contact surface. Theoretically, when the wear scar diameter increases due to the increment of applied load, there will be a higher shear stress due to a frictional contact and can produce severe wear. Next, wear scar diameter for palm oil is about 0.9% larger than engine oil at high load, which is 200 Newton. It is because palm oil will oxidize rapidly towards oxygen and has poor viscosities, which will behave irrelevant when it comes to high temperature and load. The palm oil will have a lower wear scar diameter compared to engine oil at low load because of palm oil has high amount of unsaturated fatty acids and create high strengths of lubricant. Next, we can see from the graph that wear scar diameter value for palm oil when mixed with molybdenum disulfide is the lowest for every load and increasing from 561.9 to 734.7 micrometer. This is because nanoparticles additive can separate two surfaces to prevent adhesion, thus improve the anti-wear behavior of the lubricant. Next, for the wear-worn surface characteristic of ball bearing, I have taken the picture of the wear scar on the ball bearing by using high-power microscope and compare between the 3 types of lubricant which vary of load. So, the justification for the first one is the wear scar surface appear to be rougher when the load is increased. This is because the existence of the layers of debris from the surfaces that had been extruded sideways. Next, palm oil produces much smoother wear scar surface than engine oil. This is because the non-breakdown of the lubricant film of palm oil, thus preventing metal-to-metal contact. However, if we see at 200 Newton of load, palm oil has similar extrude sideways with engine oil. This is because at high load, the pressure will become higher and cause temperature to rise, thus produce the extrude scar. Next, as we can see, for palm oil when it mixed with molybdenum disulfide, has the smoother surfaces compared to palm oil and engine oil. The reason behind this is because molybdenum disulfide can perform a better protective layer on the ball surface and has better anti-wear properties. The conclusion for this project is palm oil, when mixed with molybdenum disulfide as an additive, has a better friction reducer at low and high load compared to palm oil alone and engine oil because it has lowest value of friction coefficient. Moreover, the wear scar diameter value for palm oil when it mixed with MOS2 increase as the load increase, but it is much lower than palm oil and engine oil. And the third one is when palm oil mixed with MOS2, it has smoother wear-worn surface and having less material transfer compared to palm oil and engine oil. So for the recommendation for the future works, I suggest that the rubbing surface between the ball bearing will produce heat generation, and it is suggested that the heat distribution on the ball bearing is taken into consideration. Moreover, include the hardness test toward the wear scar to observe change of material properties. This is my reference for this project, and that's all for me. Thank you.